Hi guys, imagine that you want to control your internet peering traffic based on real-time network statistics such as bandwidth utilization of internet peer links or delay, packet loss, or internet BGP route, or else. Let's say you want to ensure that your high-priority internet user will always be able to download through the shortest path, direct peer link, and your low-priority internet user can only download through this direct peer link based on bandwidth utilization of this direct peer link. And you want the network to do it automatically, monitor, detect, and provision it in such a way without your manual CLI. In this video, I'm going to explain and demonstrate how to leverage telemetry in Peering Fabric network automation with Cisco Peering Platform, Cisco Segment Routing and Cisco NSO Network Service Orchestrator. Cisco Peering Platform can stream model-driven telemetry up to per 1 second interval so that Peering Fabric network automation can modify the network policy in real-time manner. This video is part of Cisco Peering Fabric demo series, and my name is Hin Woto. I'm a Cisco Technical Solution Architect, a CCIE, and a CCDE. You can get more information of Peering Fabric network automation. Just please sign up to ciscolive.com and access to this Cisco Live session, Intelligent Peering Fabric Network Automation Use Cases. There are complete slide deck and demonstration video.
Okay, now let's continue on the next use case, which is the peering traffic control based on the traffic SLA. So, this is the open source platform used for the telemetry stack. I use a pipeline for the model-driven telemetry collection service, InfluxDB for the time series database, and Grafana for the visualization. And for the data processing engine and event-driven action trigger, I have used a capacitor. Capacitor will trigger NSO through the REST API call, and NSO later will configure the peering traffic policy right here. So this is the Grafana GUI, Grafana GUI. This is the Grafana GUI, and I have configured the router 6. Here. In this case, in this use case, I use a standalone internet gateway or peering fabric node router 6 located on the overseas. And then it has 3 peer links here directly into the router 5. Another is router to the router 8 and via router 7. So the telemetry stack will receive the streaming telemetry statistic from router 6 or the internet gateway 6, and later it will communicate to the NSO, and NSO will configure the internet gateway policy for ingress or for egress. So let me show you the router 6 telemetry model configuration. So here, this is the telemetry model driven configuration on the iOS lifestyle on the router 6. We have the destination group. This is the IP address of the pipeline IP address or the telemetry server using the encoding Google Photograph and Google RPC here. And we activate the sensor group and router will monitor the telemetry model driven data, MDT, with this sensor part. This is for the data rate, generic counters, the BGP instance info, and also for the IPSLA. Actually, I have activated the IPSLA graph too on the Grafana. And this sensor, we will package with the destination telemetry server or collector in this configuration. And we will monitor it with a sample interval 1000 milliseconds, meaning 1 second. SNMP couldn't reach this capability. And SNMP with the pull, different from this telemetry with the push from router. Right here. Okay. Then that's a bit about the telemetry. Then here, I will generate the traffic flow from router 5 using ping with the payload. 3 ping to simulate the AS6 cloud, which is a gold customer in our example in the beginning, and -1 and -2 for the silver customer. Let's do that. Here I have prepared. I have activated the monitoring interface rate on router 6. Here this is 0, no traffic for the incoming. On the Grafana, this is the green graphic for the input. So I just monitor the input. Actually, I can change for the output traffic. Let's see on the input only, green. This is the AS5. This is the interface of router 6 towards the router 5, AS5, AS8, and is the AS65000 or router 7. So I put it in this manner. So before that, let's configure the Internet Gateway 6 first, right? Here, I'm going to add Cloud 6 gateway. And then the Cloud 6 gateway is part of the overseas gateway. At this moment, this is 60. I don't define low latency and low cost peer in this use case. Okay, let's advertise these 3 customer prefix: AS6 Cloud, AS6 Cloud 1, and AS6 Cloud 2, and commit, and show route BGP. Okay. Commit. Okay, done. That's good. And then, so let's verify the path here from router 5, T1 AS6. It goes direct because there is a direct link. 6 and 1 also go direct, right? And 2 also still go direct. That's good. Then let's let me put this preparation first. Okay. Yes, on the AS6. Okay. Now I will generate the traffic. I will use this ping AS2 cloud and with the size of payload from router 5 towards AS6 cloud, and this one towards the destination AS6 1-1. Okay. And also this. So let's monitor on the router 6 first. Okay, every flows comes to gigabit interface 0/0, which is the AS5. Now it's around 3.3, right? It's rising. And our policy is once our policy here, once the traffic utilization above 5 Mbps, it will then configure the ingress policy to offload this to the other peer link. Okay, almost there. Let me prepare to check on the on the NSO, right? Once it's across once it's across 5 Mbps, the capacitor will trigger NSO. Yeah, let's see that the incoming already across 5 Mbps. Then let's check on the NSO. Okay, I see on the NSO CLI we have rest here, right? Already sent out the rest. Then we expect, okay, the other silver customer traffic have been offloaded to the other peer link. Here we start seeing traffic flowing through AS8 and AS65,000, right? Then let's check on the trace route on the path from router 5, whether it's really which traffic goes to the other which path. So AS6 is our gold customer, should go directly to router 6. Okay, we see that's direct to 6, right? Then -1 goes to 8 here. So here, the AS8 here, this is the traffic flow of AS6 cloud -1. Okay, and then for the AS6 2 goes to 7. See here, 7, right? So this is the traffic flow of customer AS6 cloud -2. So if you see on the monitoring part, so now the traffic flow of the incoming has been distributed and offloaded, and we can prioritize the gold customer traffic with the better or the best performance without any congestion link there. And assuming that this first or gold customer traffic has finished, I'll stop this, right? Yes, we have the policy here. Once the traffic already, when the gold customer traffic already finished, then below half max, the other customer traffic can use again and can direct link from 5 to 6 here. And let's see here. Okay, now here 5 half max around here. Start decreasing across the lower threshold, and then on the other graph we see decrease flow here because the traffic flow of these two customer traffic already goes or go back to this direct link AS5. We check here on the traffic part verification on 1 first. Now it's go direct again. See here. And then for 2, yes, the same. Right. See here, we can see that using the telemetry solution, we can combine and integrate it with our traffic peering control. Then we can have the peering traffic control based on the network SLA. We actually we can monitor the IP SLA, the latency jitter here. Here, this is the AS5 peering latency from router 6 point of view, the packet loss, the jitter. We can monitor it from this telemetry stack. And we can use this statistic as our baseline policy to make the network changes through NSO. Sounds cool, right? And this is the AS65 peering latency. I monitor it from the router Internet Gateway 6. Yeah, of course, for the IP SLA, I also activate the IP SLA configuration on the router 6. And here we can also monitor on the Internet Gateway 6 how many BGP peer sessions established at this moment? 3, right? To AS5, AS8, and AS65000. So many steps that we can monitor through this telemetry and near real time, I can say so. You can see the demonstration here, right? So that's conclude our peering use case based on the telemetry. I hope you guys can follow the demonstration and really see the benefit of this intelligent peering fabric automation. So I like you guys to have the key takeaway. We have addressed and we have built our automation to solve all these peering use cases. The ingress peering automation, the incoming based on low latency, based on low cost, based on telemetry, right? And also the egress, the outgoing, the outbound automation based on this parameter all together. As well as we can have the inbound, the ingress, and the egress outbound resiliency with prioritization. Very simple manner. Just a matter of click and define it on the NSO or through a REST API for all together policy. And we also can leverage NSO capability to automate the gateway policy motion in case you want to swing from one gateway to another gateway for the policy. And we can have the very specific destination policy, as well as it's very scalable. We can start from our integrated standalone internet gateway to our distributed peering fabric. So the peering fabric solution that I have just demonstrated is consists of this network design, our Cisco Peering Router Platform, iOS XR is the key, and Cisco iOS XR telemetry as well. We can combine with the crosswalk or open source telemetry stack. The segment routing is the very key factor here. You can see here. It's very flexible, very granular, and very simple to configure, as well as the ODN, on-demand XOP, and path computation element, and of course, our main automation software, NSO, Network Service Orchestrator. Okay, so it is the variety design. It's very reliable. It can be very scalable, can be very granular, telemetry based, and very fast. You can see I have done all the use cases within this less than 2 hours, I can say so now. Very faster time to revenue. We can optimize our peering utilization, and of course, most importantly, we can improve our customer internet service experience. So I like to record this Jack Wells quotation. I think very good. Control your own destiny, or someone else will. In our case, control your own multi-cloud and peering traffic, or something, or someone else will. That's from the Peering Fabric Network Automation. So this is the additional peering resources you can revert to. Please take a look. It's very good document, very well documented, and a lot of resource. I love this all blogs and the segment routing resource. Very good books from Clarence and Chris, which are segment routing books part 1 and 2. Looking forward to part 3 for the SR physics, as I know. And yes, please check my YouTube channel as well. I have recorded some segment routing use cases, as well as with the segment routing policy or path computation element and NSO in terms of the transport and VPN service and architecture of transport as well. I think later I will add more video recorded there. And also the segment routing channel on the YouTube. Yeah, that's very good. I think, hope you get very useful this session. Thank you. Feel free to reach me for any update or for any concern. Thank you very much.